All right, let's get started again. Aircraft fuel systems. Moving towards the last few topics in this subject, we're going to cover fuel pressure warnings or fuel pressure indicating gauges. So let's take a look at that a little closer. Sound is good. It is continuing to record, so I guess I'll move right into the presentation. A fuel flow meter indicates an engine's fuel use in real time. So how many ounces per minute or gallons per minute. So you can basically gauge how quickly you're using the fuel. So the pilot can ascertain engine performance, and also there's some flight planning calculations that go into it based on your current fuel use. This is the range you could expect. The simplest fuel flow sensing device is used in connection with fuel injection systems installed on horizontally opposed reciprocating engines, which is our most common aviation reciprocating engine, the horizontally opposed. There is a fuel flow sensor. It's a pressure gauge. It's not exactly the type that's turning a turbine or turning a vane. It's actually a pressure gauge, but it is calibrated in gallons per hour or pounds per hour. All right, so per hour as opposed to per minute. The fuel flow meters for turbine engines, since that type of fuel has the largest density, the temperature variation in fuel composition does change apparently a little bit more than with regular aviation gasoline. An elaborate fuel flow device is used on these aircraft, and it measures fuel mass for accurate fuel flow indication in the cockpit. A mass flow indicator takes advantage of the direct relationship between fuel mass and viscosity. And you can see the outside appearance of the various flow meters. This one here is using little cylinders. Fuel is swirled by a cylindrical impeller that rotates at a fixed speed, and you can see the impeller that is actually turning at a fixed speed. It is actually moving the fuel downstream to make it turn a turbine. The outflow deflects a turbine just downstream of the impeller. The turbine is held with calibrated springs, last two items, downstream. Since the impeller motor swirls the fuel at a fixed rate, any variations of the turbine's deflection is caused by the volume and viscosity of the fuel. The viscosity component represents the mass of the fuel. All right, so the impeller motor is actually rotating at a set amount, and based on the viscosity and the mass of the fuel that is being pushed from the standard speed impeller to turn the turbine, it's set up to measure on an indicator the fuel flow in gallons or pounds per hour. What characteristic of the fuel is measured with the mass fuel flow? And I said that wrong. With the mass flow fuel flow meter that is used with turbine engine aircraft. So So what's the characteristic of the fuel that's measured? It's like the mass or the weight of the, well, it already says mass in the question, mass flow. So basically it is the weight or the viscosity and the density. Throw out all the words. One of them is going to stick. The density, ooh, I think we squeezed it in at the last second. The density of the fuel. You know, if you could stumble your way to the correct word, I think they may not even require the word if you can get in words like weight or mass, but mass is already kind of given, so I'm not going to give you as much credit for that. Similar question, what is used as a flow meter for a fuel-injected horizontally opposed aircraft engine? Well, we already saw that. A flow meter actually for fuel injection is normally a pressure gauge. It doesn't actually measure the fuel as it's actually flowing. It measures its pressure. And that's basically what we're talking about is pressure measuring devices. And so it's ordinarily used in a fuel-injected reciprocating engine. And it measures the pressure drop across the injector nozzles in the engine. It's nice if you can go a little further and actually point to the precise point, point to the exact spot that is being measured. And if it's fuel injected, you're going to measure right at the injector nozzles. Because you want to see how much fuel you're injecting, at what rate or at what flow. Fuel pressure gauges, you'll see a repetition of a lot of these concepts through multiple subjects in this area. And pressure gauge, the most common is the Borden tube pressure gauge. And it is fairly well illustrated on the screen here. There is a Borden tube, which, based on the pressure that's inside the tube, will actually straighten or contract. And at that action, hooked to this link, and the pinion will actually, and the hairspring will actually turn an indicator pointer. And that's basically how it works. So the actual pressure in the line is what's giving you a pressure reading. And that could actually be hooked up to wherever you're taking the reading from the pressure through the pressure connection. That gives the pilot early warning of a fuel system related malfunction. Verification that the fuel system is delivering fuel to the fuel metering device can be critical. Simple, light, reciprocating engine aircraft typically utilize a direct reading Borden tube pressure gauge. It is connected into the fuel inlet of the fuel metering device with a line extending to the back of the gauge in the cockpit instrument panel. So basically it's mechanical. I guess it's kind of chemical because there's a chemical that is actually inside the Borden tube, or a gas. But there is no electricity attached to this, and it's basically through gears and links. It's an actual mechanical connection to the gauge. Instead of a Borden tube, many instruments use these bellows. I think of it as a little handheld accordion, where bellows, which I think we'll see a slide on a diaphragm, or a single bellow. I think it's called a diaphragm, or it's just one section. Here you can see there's 5 sections on either side, and you're actually getting pressure on 2 sides, and depending on how much pressure you're getting, one or the other, there's going to be a difference in pressure, which is going to turn the mechanical connection to the indicating pointer, depending on whether the pressure is greater on one side or the other. What is the comparison? It's the fuel inlet pressure to the air pressure at the fuel metering device. All right, fuel inlet pressure, right? Where would that be? In the fuel tank? All the way to the fuel metering device, like the carburetor. A bellows type pressure gauge is normally used. Fuel pressure gauges indicate whether the proper amount of fuel is being delivered to the carburetor. You get a little more accuracy with the bellows because it can cover a greater amount rather than the Borden tube, which might have a limited range. This has a much greater range. True or false? A fuel pressure gauge is a differential pressure indicator. Well, we saw it clearly with the bellows because we did see the two sides. In the Borden tube, there was actually 2 tubes going out of the bottom of it, and so it's going to read the difference at the fuel inlet and the fuel metering device. So that's true, it is a differential pressure indicator. True or false, second part. A fuel pressure gauge indicates the pressure of the fuel entering the carburetor. It's not a terrible answer. That is approximately where you are taking the fuel pressure measurement. I'm going to say that that's true also, although I could see where schematics are going to say, well, it's the difference of the 2 pressures, but this one, I feel like I'd be nitpicking to disagree with it. It is also true. All right. So don't nitpick. Fuel pressure warning system. Tied right into it. So this way, I suppose you don't have to monitor it continuously, especially when you have dozens of gauges. But basically, a warning system senses the pressure at the carburetor inlet, generates an electrical signal to give the first indication that a tank is empty and that the selector valve should be switched to a fuel tank. And we can kind of see fuel pressure up here on the top, the 4th one over. Fuel pressure warning. You can see a few other warnings too. Oil pressure. If there's a clogged filter, there's an indication. Anything else for fuel? Low fuel. It's going to be about it for fuel. As soon as the pump begins to draw air from the tank, the fuel pressure drops and the pressure warning system contacts close, sending an electrical signal which turns on a warning light or flashes a warning on an annunciator panel. So it's either a warning light or a flashing warning. It's not a audible warning. To prevent exhaustion of fuel in one fuel tank, Pressure warning systems are installed in some aircraft. The installation consists of a pressure-sensitive mechanism and a warning light. The warning system has both a fuel and an air connection. The connection marked fuel is connected to the fuel pressure line of the fuel metering device, and the air connection is either vented to the atmosphere or to the air inlet side of the fuel metering unit. Pretty much everything we've already talked about. It's a fuel pressure. It's measured at the carburetor or the fuel metering device, and the other side is either vented to the atmosphere or the air portion of the fuel tank for better visibility, which should equal the atmospheric pressure. And sometimes they're under pressure. I'm not sure whether or not I'm not sure when we cover that. Maybe in pressurization, so don't worry about that right now. Okay. I mean, it's an interesting drawing. I can see my research has been started to improve at this point. In some aircraft with several fuel tanks, the possible danger of allowing the fuel supply in one tank to become exhausted before the selector valve is switched to another tank is prevented by the installation of, is it A, a fuel pressure warning signal system? Yes. Or is it B, a fuel pressure relief valve? No. Or C, an engine fuel pump bypass valve? Engine fuel pump bypass valve. If there's no fuel going into the fuel pump, it doesn't matter whether or not there's a bypass valve. So basically, to prevent one tank from becoming exhausted or emptied before you can switch to the other tank is A, the fuel pressure warning signal system. A fuel pressure warning switch contacts close and a warning light is turned on when would the fuel pressure warning switch contacts close? In other words, the remote switch is closed, or the relay, and the warning light is turned on when A, a measured quantity of fuel has passed through it. So does it keep track? No. B, when the fuel flow stops, that could be it. Or C, the fuel pressure drops below specified limits. Much more accurate. And it is a pressure sensing and indicating system, so that's definitely the best answer. Which of the following would give the first positive indication that a changeover from one fuel tank to another is needed? All right, now we're hammering on the same question, same answer. This time we do have two options that say fuel pressure, so let's explore the difference. And this is the first indication that you have to change tanks, not necessarily the fuel quantity indicator, which it isn't a positive indication. It's basically something that you read. So it's going to be fuel pressure. What is it? A fuel pressure warning? So far, yes. Or the fuel pressure gauge? Well, you could have both. You can actually read what your fuel pressure is, but the first positive indication is going to be that little red light coming on or flashing that says fuel pressure. Fuel pressure warning. I probably overtalked that question. Apologies. How do you adjust the pressure? Is that what we're going to talk about? The pressure sensitive mechanism is generally a bellows, and that can actually be adjusted to change the pressures at which it actuates. Maintenance and troubleshooting procedures for fuel pressure warning systems are found in the manufacturer maintenance manuals. But you can see where the adjustment screw is. And if you apply a certain amount of pressure and it's you want it to read exactly on that knot, on that little hash right there, that little radial, you can adjust it so that the pointer goes exactly there if you're applying the correct pressure. Probably rare that you would do that, but it's more important that you understand the concepts of how and why you would do it. What unit would be adjusted to change the fuel pressure warning limits? All right, so they are going to ask you a question like this. Is it the fuel flow meter bypass valve, B, a pressure-sensitive mechanism, or C, fuel pressure relief valve? A very tricky question. Generically, the most general answer would be the pressure-sensitive mechanism. In order to change fuel pressure warning limits, what unit do you adjust? The part that's actually sensing the pressure, that mechanism, that's what's going to be adjusted. If it had possibly the indicator itself, well, it wouldn't be the indicator. It would actually be the warning light. So it would have to be the pressure-sensitive mechanism. The fuel pressure relief valve doesn't really have anything to do with the pressure warning. That's mostly so that if there's excess pressure, it will be relieved from the system. Nothing to do with the warning limits. We're actually warning of low pressure, not high pressure, which is what a pressure relief valve protects against. The bypass valve and a fuel flow meter really has nothing to do with what we're talking about. So yes, it's a pressure-sensitive mechanism. Just a generic description of the mechanism. Since we're adjusting the fuel pressure mechanism or the pressure sensitive mechanism, what is that usually? That could be a called a sensor or a probe or a bulb. I'm seeing one on the lower left of the screen. Fuel pressure is an important parameter that merits the use of a warning signal when it falls outside the normal operating range. Low fuel pressure warning lights can be illuminated through the use of simple pressure sensing switches. Is that what I'm showing here? There's going to be an electrical connection to the warning light, and so you're getting the two pressures, the fuel pressure and the air pressure. So you are measuring a difference. Both those pressures are going to different sides of a diaphragm, which let's say it just, if there's more pressure coming in the bottom, it's actually going to push the bellows up, and it may open or close the contacts depending on how you configure it. And there's an adjustment screw that goes on to that. It, in effect, transmits that signal through the electrical connections to the warning light. In this case, it wouldn't be, it wouldn't have to be calibrated or anything, because it's just, the contacts are closed, the light goes on. A more complex aircraft may have a sensor with a transducer located at the fuel inlet to the metering device that sends electrical signals to a cockpit gauge. So you may see a question on a transducer. You don't run across those too often. I am able to show you a couple on the screen and a definition. The definition is it's an electrical device that either takes electrical energy and changes it into mechanical movement, or takes mechanical movement and changes it into electrical energy. Interesting. And that's at the fuel inlet to the metering device. All right, I can't say I'm an expert at these. A transmitter in a fuel pressure warning system serves what function? So what function would the transmitter in the warning system serve? Does it A, transmit an electrical signal to fluid pressure? Or, not exactly true, it does transmit an electrical signal. Or does it B, converts fluid pressure to an electrical signal? It's not actually the job of a transmitter to do any converting. Or does it C, transmits fluid pressure directly to the indicator? All right, well, I like the fact that it's going to the indicator. So a transmitter transmits to an indicator in pretty much 99 times out of 10. So may not be the best written question, but a transmitter transmits to an indicator. C. Oh, all right, this one's bad. I don't know if I would get that one. A transmitter converts fluid pressure to an electrical signal. Okay, I have to accept that because, yeah, the word directly, I guess I was floating over that. I liked the transmits to the indicator so much that I ignored the word directly. All right, I suppose now that I'm reviewing it, I can understand that. Don't jump on that word. Don't jump on 3 because of the word directly. Yeah, a transmitter does convert the fluid pressure by use of the bellows or whatever to an electrical signal. Basically, it's a switch that opens or closes. And then the annunciator panel will have a warning, a little red warning flash. All right, a transducer in a fuel pressure system serves what function? There's your transducer. Like I said, it's not my strong suit, so let's see what it is. A, does it transmit an electrical signal to the transmitter for fluid pressure? Or B, does it transmit electrical signal proportional to the fluid pressure? Or does it C, convert fluid pressure directly through a transmitter to the indicator? All right, I guess these are the tough questions for fuel. I didn't do that well in the last one, the transmitter. I don't actually expect to explain this one any different. We did look at the definition of a transducer, and that changes mechanical energy to electrical energy or vice versa. Okay, that is a conversion. Let's see if this conversion fits. Converts fluid pressure directly through a transmitter to the indicator. You know, I can't say I hate the word. The other ones, are they any better? Transmits an electrical signal to the transmitter. Ooh, wrong. You don't transmit to the transmitter. You transmit to like a receiver. B, transmits electrical signal proportional to the fluid pressure. It's kind of the same. That might actually be a better answer. All right, I don't know. I think I'm going to switch from C to B. But I wouldn't be surprised if it's C. It continues to be C. A transducer converts. It changes energy from one form to another. All right, these are tough questions. I'd review them. Obviously, they're tough. I'm not doing that well at them, and it has been a few years since I've looked over this material, but still, I've covered it enough that I should have the stuff cold. Well, I guess in a way we're learning together. I'm just maybe expanding my learning to a little more permanent state. We'll see. I'll have to do this again in 2 years and see what type of answers I come up with. Somebody who's prouder might quickly record a new one where they get all the answers correct. I suppose if I get a third one wrong, I might have to re-record the video, but we'll see. Where is fuel pressure taken for the pressure warning signal on most aircraft engines? All right, I think we know this one. Is it A, the outlet side of the boost pump? B, the fuel pressure line of the carburetor? So far I like that one. Or C, between the fuel pump and the strainer? So now the fuel pressure is going to be very close to that fuel metering device, not somewhere way upstream in the system. So B. I guess it says most aircraft engines, but most if not all. Which of the following is necessary to effectively troubleshoot a fuel pressure warning system? Okay, you want to make sure that warning system, you want to make sure the light comes on at the proper pressure. So what are you going to refer to? Are you going to refer to the manufacturer's maintenance manuals? Not a bad answer for any of these questions. B, the AC 43.13-1B, acceptable methods. We'll just call that the AC, which is almost like an older FAA textbook and how-to book. But it's not specific enough to tell you the specific pressure that's going to be developed for the fuel pressure warning system of that aircraft. Or C, a set of FARs. And you may get the requirement that you are to measure fuel pressure, but you are certainly not going to get told what the fuel pressure is. So now you'd have to go into the manufacturer's maintenance manuals, plural. And hopefully they are detailed enough to give you a step-by-step instructions on how to do that. How are we doing for time? Looking good enough. This instrument is used in turbine engine aircraft to measure fuel flow. A flow sensing device that measures pressure. B, a pressure gauge calibrated in gallons per hour. No, because of the gallons. C, a fuel flow device uses fuel viscosity to calculate mass. Well, they're saying all the right words. Or D, a sensor that uses a vane and calibrated spring. Not for turbine engine aircraft, for a smaller engine. So C looks great. Okay, since we're measuring fuel flow, we're actually the viscosity and the mass. So I'm not sure why I stuck this under the section of pressure measuring. Just because of the section it's in, I'd almost think that the correct answer is A. But I'm not going to go with that. It's close between A and C. I'll take a loss if it's not. I'm going to stick with C mostly because it uses three good words: fuel flow, viscosity, and mass. Three balls and you walk. I'm not sure what the expression would be. Yes, the turbine engine fuel flow. It's the impeller sending the fuel to turn the turbine, which is attached to two calibrated springs, and the measurement is taken based on the viscosity and the friction and the movement, the relative movement through a wired device, which it looks like it's a synchro type device. So whatever happens on one side is going to happen on the indicator side, and then you can just connect the two with wires. I think I said it well enough. Microprocessors have enabled the integration of fuel flow measurements with fuel temperature sensors consisting of two. All right, so basically this is where I still had the slides after the question. Some of these I've been looking at ahead of time and moving the slide ahead, so we've already talked about this. But basically, what does RTD stand for? I'm going to see if I can remember this. Microprocessor, integration of fuel flow measurements with fuel temperature sensors. Well, I'm going to go with one of the drivers. That's C or D. And I'm going to go as generic as possible. C. Shot? Oh, it's B. Resistance temperature detector. All right. I don't know why that was probably the only words that actually made sense of all of them. But all right, let's see what my text has to say about that. Increasing use of microprocessors and computers on aircraft enable the integration of fuel temperature and other compensating factors to produce highly accurate fuel flow information. Fuel flow sensing with digital output facilitates this with a high degree of reliability. Thermal dispersion technology provides fuel sensing with no moving parts and digital output signals. The sensor consists of two resistance temperature detectors. One is a reference RDT that measures the temperature of the fuel. The other is an active RTD. It is heated by an adjacent element to a temperature higher than the fuel. As the fuel flows, the active element cools proportionately to the fuel flow. The temperature difference between the two RTDs is highest at no flow. All right, I'm surprised I found a question that covered it. But you never know. FAA is looking for new questions. These are published questions, and I should have been a little better at giving you the most probable answer. Microprocessors kind of threw me off a little bit from resistance, even though resistors are used extensively in electronics. I was a little hesitant to use it in this context. So my bad. So feel free to definitely use it. It's a detector, and it is a resistance temperature detector. These devices let a pilot be sure that the fuel system is delivering fuel to the fuel metering device at a sufficient rate. Well, that would be our fuel pressure. Let's see if any of them have it does say fuel pressure gauge here, so I'm going to say that that's what we're looking at. The flow meter isn't a terrible answer either. Which I believe flow meter even takes under its umbrella fuel pressure gauges. Nah, I'm going to stick with fuel pressure gauge. Before I really have to record this. And after 41 minutes, I don't think so. Monitoring fuel pressure can give the pilot early warning of a fuel system related malfunction. Verification that the fuel system is delivering fuel to the fuel metering device can be critical. And here you can see they do have a fuel differential PSI or pressure, pounds per square inch. And what do we have on the other side? An electronic display of the fuel parameters, including pressure. You can see the PSI. There's also gallons per hour and some calculations based on that, like the range. The fuel flow meter used in a fuel-injected horizontally opposed engine is we saw that way back. What is that? It was a pressure gauge because the fuel injected. That's really close to the question we already seen. So it's a pressure gauge. And here's an example of a fuel injected unit, and you're going to read the pressure close to the injectors. So in this case, there's 4 injectors. Okay, here's the fuel nozzle. It is taking the pressure from the nozzle. I would imagine that's what this little blue line on the top is for. And the vane type again. Right, I did mention in the previous slide, it's not shown here, but the electrical connections is the auto SIN, where it basically has the circular type of schematic, wire schematic, which is connected to a similar circular schematic on the indicator. A modern fuel management gauge uses a microprocessor to display fuel flow and numerous other fuel consumption related calculations. We saw that with our DTs. RM. Okay, forget it. We did see this illustration already. You can turn it to gallons to destination, gallons reserve, endurance, etc. So you've got some other ways you can actually turn. You have a test button there also. A transducer and microprocessor for control functions are located in the base of this turbine fuel flow sensor. The gauge is menu driven with numerous display options. Turbine flow transducer on the left. It produces a current pulse signal from an optoelectronic pickup with a preamplifier. And on the right we have fuel flow sensing units that use thermal dispersion technology and have no moving parts, and it outputs a digital signal. Something from the textbook. You can actually find this in a reading that we had for fuel quantity indicators. There was a little section on fuel pressure gauges and even a paragraph on fuel temperature gauges. Okay, nothing new here or here. A little bit of a review of what we've already looked at, it looks like. This one looks new. Transport category aircraft fuel panel with low pressure warning lights for each of the fuel boost pumps. And that's the end. Alright, I appreciate you guys hanging with me. I can see that we're going pretty late here, so go ahead and take a break. We've only got a couple more to go, and we can actually put this subject to rest. So thanks for joining me, and I'll see you on the next one. Goodbye.